Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals, More Examples. In this presentation, we will be solving example problems related to indefinite integrals. Let us look at an example which involves radical terms and exponential terms. Let us evaluate this indefinite integral 4 square root of v minus 3v to the power of 3 over 2 dv. So when we have functions of this kind, we want to convert the radical terms to exponential terms and then be able to apply the process of integration. So square root of v we can write as v to the power of 1/2, and therefore we can rewrite the given function as y is equal to integral 4v to the power of 1/2 dv minus integral 3v to the power of 3 over 2 dv. So now when we see constant terms inside of the integration process, we can take them outside of the integration process as shown here. Y is equal to 4 integral v to the power of 1/2 dv minus integral minus 3 integral v to the power of 3 over 2 dv. Now it is in the process, it is in the form of a power rule, so we can apply the power rule and apply the integration to each one of these functions and then be able to arrive at the answer. So regarding power rule, let us see what the power rule is stating. If y is equal to integral x to the power of n dx, then the power rule is when we apply the power rule, we can write it out as x to the power of n plus 1 divided by n plus 1 plus c. So whatever we have in as n as an exponent, we're going to increase it by 1 and then write the same term in the denominator as shown here. So let's go back to our example. So we have 4 times integral v to the power of 1/2. In our case, n is equal to 1/2. So we're going to apply the power rule here. 4 times v to the power of 1/2 plus 1 divided by whatever we have in the power term, we're going to write it in the denominator as 1/2 plus 1 minus 3 times integral v to the power of 3 over 2 dv we can write as v to the power of 3 over 2 plus 1 divided by 3 over 2 plus 1 plus c is a constant of integration. So now when we simplify this, we can write this as 4 times v to the power of 1/2 plus 1 translates to v to the power of 3 over 2 divided by 1/2 plus 1 translates to 3 over 2. So therefore, we can simplify this one as 4 times v to the power of 3 over 2 divided by 3 over 2 minus 3 times v to the power of 5 over 2, that is 3 over 2 plus 1 translates to 5 over 2 divided by 3 over 2 plus 1 translates to 5 over 2 plus c, which is where c is a constant of integration. When we simplify it some more, we have 4 as a constant term. When we have 3 over 2 in the denominator, when we bring it to the side of the term, it translates to 2 over 3. So 4 times 2 is 8 over 3, and that is what this term is here, times v to the power of 3 over 2 minus 3 times the term in the denominator we have is 5 over 2. When we bring it to the side of the term, we can write that as 2 over 5. So 3 times 2 is 6 over 5, and that's what the 6 over 5 is, times v to the power of 5 over 2 plus c, where c is a constant of integration. So this is our solution. So when we have terms involving radical, when we have an example problem involving radical terms and exponential terms, we should be able to convert the radical terms to exponential terms and then be able to apply the process of integration, be able to apply the basic rules of integration, and then solve the problem as shown here. Let's look at another example. Let's say we want to evaluate this indefinite integral 15x times square root of x plus 2 square root of x dx. So we have we have some radical terms. We want to convert those radical terms into exponential terms. So we can write square root of x as equal to x to the power of half. So therefore, when we write that, we can when we convert the radical terms into exponential terms, and then write it as an expression, we can write it as shown here. Y is equal to integral 15x, which is the same as that, times, instead of square root of x, we've replaced it by an exponential term, which is x to the power of half, plus 2 times square root of x, we can write as x to the power of half as shown here, the whole thing dx. Okay, now we want to combine the like terms. If the bases are the same, we can combine the power terms. So in here, we want to combine x times x to the power of half. Since the bases are the same, we're going to write the base term once. And the one of the rules of exponents is stating that when the bases are the same, we can add the powers. So x means x to the power of 1, 1 plus 1 half. So 1 plus half is equal to 3 over 2. So x times x to the power of half is equal to x to the power of 3 over 2. So now we can put all of these things together and then rewrite the given function as y is equal to integral 15x to the power of 3 over 2 plus 2x to the power of 1 half dx. Now we can apply the integration process to every one of the terms as shown here. Y is equal to integral 15x to the power of 3 over 2 dx plus integral 2x to the power of 1 half dx, like that. Now, since we have some constant terms, we're going to pull that outside of the integration process. Y is equal to 15 integral x to the power of 3 over 2 dx plus 2 integral x to the power of 1 half dx, like that. Now we are ready to apply the ready to integrate each one of these functions separately. We're going to apply the power rule. Let's state the power rule one more time. If y is equal to integral x to the power of n dx, the power rule is stating that we can write this as x to the power of n plus 1 divided by n plus 1. X to the power of n can be written as x to the power of n plus 1 divided by n plus 1. And here n can be a whole number, or it can be a fraction, or it can be a positive number, or it can be a negative number. So we're going to apply this to our example problem. So let us see how that works. So 15 times integral x to the power of 3 over 2 dx can be written as 15 times x to the power of 3 over 2 plus 1. In our case, n is equal to 3 over 2. It is a fraction. So divided by whatever we have in the power term, we're going to write that in the denominator, 3 over 2 plus 1, n plus 1, plus 2 times integral x to the power of half dx. That can be, when we use the power rule on it, it translates to x to the power of 1 half plus 1 divided by 1 half plus 1. In this case, n is equal to 1 half. So when we simplify it some more, it translates to 15 times x to the power of 3 over 2 plus 1 translates to 5 over 2 divided by 3 over 2 plus 1 translates to 5 over 2 plus 2 times x to the power of 1 half plus 1 translates to 3 over 2 divided by 1 half plus 1 translates to 3 over 2 plus c. So 15 times 5 over 2 in the denominator, when we bring it to the side of the expression, it becomes 2 over 5. So 15 times 2 is 30 divided by 5, which translates to 6. So that is 6 times x to the power of 5 over 2 plus the next term is 2 times the denominator term. When we bring it to the side of the expression, it translates to 2 over 3. So that is equal to 2 times 2, which is 4 divided by 3, excuse me, times x to the power of 3 over 2 plus c. So this is our this is our answer. So where c is a constant of integration. So our answer is 6x to the power of 5 over 2 plus 4 over 3 x to the power of 3 over 2 plus c, where c is a constant of integration. So when we have radical terms in the example problem, We want to first convert those radical terms to exponential terms and then be able to solve the problem and then arrive at our solution. This is the way we're going to solve the problems. In my next video presentation, we will be solving some more examples related to indefinite integrals.